using patterns and formulas. So this section is a follow-up section to the online notes video that you should have watched previous to this one. And that was the one that showed us the difference of two squares and the addition of two squares and what the routine was like for those. So for this one, looks like we're going to be using the difference of two squares for both of these, and we're going to follow this pattern, and we are going to factor the two polynomials given to us. So if we look at this first one here, we have x squared minus 21. So we learned from the other video, we want to get this side to be written as the left side squared minus the right side squared. So right now, the left side, the a squared side, is already squared, so there's nothing we have to do there. But that 121, we need to write that as a number squared. So we can rewrite this, right? So this stays x squared. So I'm just rewriting like this so it's consistent. Minus, this is going to be 11 squared, right? 11 times 11 gives us 121. So looking at that, now we have a difference of two squares. We have a squared minus b squared. So we know that a is going to equal x and b is going to equal 11, right? And we just pull them out of here. So we learned that for the difference of two squares, this is our pattern here. Our pattern is going to be a minus b, so our pattern is x minus 11. And then the other factor is going to be a plus b, which is just x plus 11. So we just filled in x's and 11's over there. So if we were to go ahead and check our work and we want to see if we did this correctly, x times x gives us x squared, right? We do the FOIL method here. X times 11 plus 11x. Negative 11x minus x gives us negative 11x. And then negative 11 times positive 11 is negative 121. Just like in the video we previously watched, these terms cancel out, and all you're left with is x squared minus 121. So that's a way to check your work. Our answer was when we left off here in the red without all this blue stuff here. Now let's look at the right one. So for the right one, again, we're using the difference of two squares. Look at formulas up here. We have 9x squared minus 49x squared. So remember that this whole side needs to be squared, and currently only that x is squared, right? The 9 and the x are separate right now. The x has the exponent of 2, the 9 has the exponent of 1. So we're looking at rewriting the 9, so it's a base to an exponent squared. And we're looking to writing 49, a number squared. So if we simplify this out, if we rewrite 9, we can rewrite 9 as 3 squared. And then this is x squared. Minus 49 can be rewritten as 7 squared. So really here we have this side, 3x squared. And I'm just rewriting it. I'm not changing the value. Because remember, this 2 gets distributed to this exponent of 1 and this exponent of 1. So this is still 3 squared x squared, or 9x squared. So we got 3x squared on the left side minus 7 squared. So we have our a and we have our b, right? And we're just going to be plugging in those for these four values here, just like we did earlier. So a minus b is the first factor. My a is 3x, my b is 7, so 3x minus 7, and then here I plug in my a, 3x plus 7. Okay, now looking at that bottom piece, so now we're going to use the perfect square trinomial, right? And for the perfect square trinomial, just focus on what the difference is, and it's going to be the factors. Right, so the factoring is a little bit different. Right up here, you end up with 2 parentheses. Up here, we're going to end up with a trinomial. So let's look at 7x plus 5. we're looking to get this to a plus b squared. These are both already given a plus b squared. This here is given a plus b squared. So first thing we want to do is identify what a is. So if you look at this, a is going to be 7x, and b is going to equal 5. So let's start plugging, let's start plugging in here. So for my first one, I know this is going to be a squared, right? And I'm looking at this here. That's a squared. This is going to be a squared. So a squared, we're going to take a, just plug it in. Here's my 7x. And we're going to square it. The next one, we're looking at 2 times a times b. Here's my 2 times a is 7x times b, running out of room, times 5. Right, that's not an exponent, that's all being multiplied on one line. And my third one here is b squared. My b is equal to 5. This is going to be 5 squared. So now simplifying these out, this first one we have 7 squared x squared. So 7 squared gives me 49. And x squared is just x squared. This one's going to be a little bit tricky, this term here. 7 times 5 is 35. 35 times 2 is 70. So this is going to be plus 70x. And then that 5 squared on the end, 5 times 5 is 25. And that's going to be our final answer. Right? So if we take 7x plus 5 and we square it, it should factor out, or it should expand to 49x squared plus 70x plus 25. And again, if you want to check your work, 7x plus 5 times 7x plus 5, and I'm going to work this out really quick. 7x times 7x is 49x squared. 7x times 5, 35x. 5 times 7x, 35x. 5 times 5, 25. Like terms, and you're left with 49x squared plus 70x plus 25. Okay, so again, this pattern makes it a lot easier when you want to expand these. All right, let's do the next one. And I'll use the same color coordinations. So for our a and b, here's our a. Our a is equal to 2x. Right, that's our a. That's our b. Our b is equal to 3y. We might run out of room for this one. I'm gonna write these in as we go, just so I can make sure I have enough room. So for my first one here, I have a squared. My a is 2x, so I'm going to have 2x squared. Then I have my plus sign from the equation. I have 2 times a, which is 2x, times b, which is 3y. I don't know why I wrote 35 here. That's odd. That should be a 3y. So 2 times a, which was 2x, times b, which is 3y. And then we have our plus sign. And then b squared. So I'm looking at this here. B squared is 3y. That's my b squared. So now we got to simplify this out. 2 squared, x squared. That gives me 4x squared. 2 times 2 is 4. 4 times 3 is 12. X times y, that we just bring that down, xy. And then finally 3 squared, y squared. That gives me plus 9y squared. And that is your expanded form. So remember, you can, again, check your work. I'm not going to do it here, but 2x plus 3y times 2x plus 3y. And you should get this answer here, right, when you do your claw method. Okay, so now introducing the sum and difference of cubes. Cubes when they're to the third power. So we're going to confirm both the patterns below by expanding the right side and matching it to the left. Okay, so we're going to prove that this side is going to be equal to a cubed, b cubed. So if I remove these, the first thing we need to utilize is the claw. So here we have a times a squared. That's going to be a cubed. A times negative ab. So that's a positive times a negative. That's going to be negative. A times a is a squared. And then we have this b here. Next we have a times b squared. That's going to be plus ab squared. Next we have b times a squared. I'm going to write plus a squared first and then my b, only because I look at this here and I want it to be consistent with that, because when it'll help with when we combine our like terms. So b times negative ab is going to be negative a, and then we had a b times b. That's going to be b squared. And then our last one here, b times b squared. That gives us b to the third. So now when we go to collect our like terms, we have negative a squared b here plus positive ab squared here. These cancel out. We have a b squared and a negative ab squared. These two cancel out. So in the end, what we're left with is a cubed plus b cubed, which is equal to a cubed plus b cubed. Right? So that's confirming that this expanded form here is equal to a cubed plus b cubed. Which makes it easier for us when we want to factor. We can skip a whole bunch of steps. And now confirming the left-hand side. So we want to start off doing the claw method again. A times a squared gives us a cubed. A plus ab gives us a positive a squared b. A times b squared gives us plus ab squared. We move on to the negative b. So negative times a positive is a negative. B times a squared b. Negative b times positive ab squared is a negative ab squared. And then negative b times b squared is negative b cubed. So when we go to collect our like terms, we look for things that are same variable. Don't know why I couldn't think of that word. Same variable and the same powers. We have a squared b here. We have a negative a squared b here. Those cancel out. We have a ab squared minus ab squared. These cancel out. So when we simplify it fully, we have a cubed left over and a negative b cubed left over, and that's equal to the left-hand side, which is a cubed minus b cubed. Okay, so again, that's confirming that both patterns below can be expanded, and pretty much it's equal to one another on each side. And to answer the question on the bottom, what patterns do you see? You can mention things like you see that there are opposite a squared b's and opposite a b squareds in your answer. So anything along those lines would get you credit if that question would be asked on a test. Okay. Now let's look at the problems that we have here. So these are the examples, and this is what we will be, this is what our homework is related to, and when we take our quiz, this is what we're expecting you to do. So we want you to use the sum and difference of cubes patterns to expand polynomials. So I'm looking at this one here. We'll do this one in red. We have m cubed plus 27, right? And these are the sum of cubes that's being added. And it gives you a hint that it's the sum of cubes because of this 3 here. It's a cube. So it looks like this left-hand side is completely cubed. But now this right-hand side, we want to write it to a number cubed. So we can make this so this is already m cubed plus 27 we can rewrite as 3 cubed. So now we have our a and b. So our a is equal to m and our b is equal to 3. So this left-hand side is done. We have this form here, a cubed plus b cubed. And now we got to work on the right-hand side. So for the right-hand side, let's put our equal sign here. And let's just start working it out. So for a, we can plug in m. Plus for b, we plug in 3. Next, we have the second parentheses where we're starting, and we have a squared there. A squared is just m squared minus a, which is m, times b, which is 3, and then plus b squared, which is 3 squared. So we have a bit of simplifying we have to do on the inside here. I'm going to rewrite this first parenthesis, m plus 3. M squared, there's nothing to simplify here. M times 3, that gives us 3m, so that's minus 3m. And then 3 squared gives us 9. So now if we look, there's nothing else left for us to simplify. And that would be our final solution for the difference, for the sum of cubes. And again, if you always want to check your work, you got m times m squared, that's m cubed. And I'll erase this after I write it out. M times negative 3m is negative 3m squared. M times 9 is plus 9m. 3 times m squared is plus 3m squared. 3 times negative 3m, negative 9m. And then 3 times 9, 27. So notice that we have a negative 3m squared, positive 3m squared, positive 9m, negative 9m. And what we're left with is that 3m plus 27. Okay, I'm going to erase all this. And then we'll move on to 16a cubed plus 54. Oops, that's the answer. All right, the next one. So we have 16a cubed plus 54. So the first thing we need to notice is 54, we can't write a number to the third power is 54. And we can't write a number to the third power is 16, right? Because if you do 2 to the third power, that's 2 times 2 is 4, times 2 is 8. If you do 3, that gives you 27. 3 to the third power, 27. Doesn't work out. But we can notice that these are both even numbers. So the first thing we can do is factor out a 4 here. Right? 4 times 4. I'm sorry, not factor out a 4. We're going to factor out a 2. Let me erase this. That's my bad. Sorry, they're both even numbers, so we're going to factor out a 2. So if we factor out a 2, 16 is 2 times 8, so 8 goes into here. So this is 2 times 8a cubed plus 54 breaks down into 27 times 2. So 27 stays inside. And now we look at our our sum of two cubes. Difference of cubes comes next. So we're looking at 8a cubed plus 27, and we see if we can rewrite those as cubes. I'm going to leave the 2 off for now, but don't forget that that's going to be included in your answer. So 8, I know I can rewrite as 2 cubed, so this will turn into 2a cubed. All right, so this is 2 cubed a cubed plus 27, like in the previous problem, we know we can rewrite as 3 cubed. Let me write that better. As 3 cubed. And again, that 2 is still out there, still lingering. It doesn't disappear. So now this is going to equal, as we're going to take, let me keep this consistent, here and here. And we're going to write what our A equals. Our A is equal to 2A, and our B is equal to 3 again. So now let's go ahead and we are going to write the equivalent to it, the one that we go ahead and factor out. So first one we have is A plus B. A plus B, this one's pretty easy. My A is 2A plus B is equal to 3 times, and this one, it's up to you if you're more familiar with using brackets, so that way when you plug in, you don't get too confused. A squared gives me 2A squared minus A, which is 2A, times B, which is 3, plus B squared and now we got to simplify. So if we look at the first parenthesis, there's nothing we can simplify there. That's just 2A plus 3. We are going to rewrite this. Here's my 2A plus 3. For my second parenthesis, I'm going to start simplifying the brackets. That's 2 squared A squared. That's 4A squared. Minus 2A times 3 gives me 6A. And then that 3 squared at the end, that is plus 9. And I go ahead and double check to see if it's fully simplified, and it is. And that is our final answer. You can go ahead and check your work. Same method. You can go ahead and distribute. I almost forgot to add the 2 out in front, right? So we have this 2 out here still. So that is going to equal to what we have here in purple. So 2A cubed plus 3 squared is equal to that there. I just don't have a room to write it in this section. And if you go ahead and check your work, you have 2A times 4A squared. That gives us 8A squared. And remember, that gets multiplied by 2, which gives you that 16A squared that we originally had. And if you look at your last one, right, this here will give you your last term. 3 times 9 is 27. And it gets multiplied by 2. That gives you 54. So, quick way to check if you are doing it correct. And that's your answer there. Let's see, I might have to erase these when I get to the difference of cubes. We'll see. So for difference of cubes, We have 8a cubed minus 27, and just so happens we pretty much just use these numbers right here. So we have an idea of how to at least start it. Let's see. I'm going to go ahead and erase these so they don't get in the way. I think that's a better idea. All right, so looking at this first one here, we have 8a cubed minus 27. So 8 we know we can rewrite as 2 to the third power, a to the third power. You can initially write it like this, or you can go straight to writing it like this. It's up to you. This middle step here is unnecessary. Oops. The middle step here is unnecessary. So we can write this as 2a cubed minus 3 cubed, right? Because 3 times 3 times 3 is 27. So now we can make our little key here. A is equal to 2a, b is equal to 3. And again, we're going to just start plugging into all these values here. So we have a minus 6, or sorry, not a minus 6, a minus b. So for a, we have 2a minus b is 3. I have my bracket here. A squared gives me 2a squared plus a times b. My a is 2a times b is 3 plus b squared, 3 squared. I'm going to start doing my simplifying. First fraction, or first parentheses, no simplifying. Second parentheses, 2 squared a squared. 2 squared gives me 4. This is 4a squared plus 6a plus 9. And if you want to check your work, so that is our final answer. Right, so this here is equal to this. And if you do want to check your work, 2a times 4a squared gives us 8a cubed. That's what we have here. A lot of terms are going to cancel out, but if you do this negative 3 times 9, that ends up giving you your 20, your negative 27. That's that there. It's up to you. You can go ahead and check these. These should cancel one another out, right, as evidenced by the original question. Okay. The last one here, the 16a cubed minus 2, this is the one that probably students miss the most because they start getting confused with that 2 there. And they just think it's a problem that can't be solved, or it's a mistake made by the teachers in the room. It's not. It is possible to solve this. 16 we can't write as a number cubed. 2 we can't write as a number cubed. So we should do what we did in this problem right here immediately to the left and factor out a 2. Right. So technically dividing these by 2. So here's our 2. We have 8a cubed minus 1. So difference of cubes, we want to go ahead and rewrite it so it's a cubed minus b cubed. Right? So the 2 is always going to stay there. Focus on the 2, these on the inside. How can we rewrite these? So 8 we can rewrite as 2 cubed. So this is 2 cubed a cubed, which is just 2a cubed. Right? So these here are the same value. They're both 8a cubed. Now minus sign 1. So 1 is that tricky number. 1, no matter how many times you multiply by itself, is just 1. So if we do 1 cubed, that's just telling us that's 1 times 1 times 1, which is 1. So that 1 can be written as cubed. Just keep that in mind every time you run into these problems. You're not doing it wrong. It's just tricky. So we write out our key. We have our a is equal to 2a. That's a minus b. B is equal to 1. So we write this out as our factors. Our first one is a minus b. So here's a is 2a minus b is 1. In parentheses, the first one we're going to have is a squared. A squared is 2a squared plus a, which is 2a, times b, plus b squared, which is 1 squared. So this one should be pretty easy to simplify. We have 2a minus 1 for the first parentheses, 2 squared, a squared, plus 2a times 1, plus 2a, and then plus 1 squared. 1 times 1 is 1. And there is our final answer. And if you want to double check your work, 2a times 4a squared gives us 8a squared. I almost forgot to do this again, to put the 2 here. Because remember we factored out that 2. And then this was a cubed minus b cubed. Keep that 2 there. I just forgot to do it twice on both the practice problems that we wrote. So very common to forget it. And I'm not just saying that because I forgot it. So going back to double checking our work, 2a times 4a squared gives us 8a cubed times 2 is 16a cubed. And then we have that negative 1 times 1, which is negative 1 times 2 minus 2. And again, all those little rest of those clauses should cancel out. It's suggested that you just check your work all the way through.